Yo, hey guys. So now it's time to learn the quotient rule. So I've got the quotient rule right in front of me, and I've simplified the notation just a little bit because the quotient rule is the one, probably the biggest one out of all the rules. Okay, so quotient meaning when we're dividing something, right? So if you have f and g, those two functions, and we're trying to differentiate this, then we have this complicated looking formula. Okay, now if you look at the numerator, it's alternating, kind of similar to the product rule, but since there's a minus, it's very important in which order we do this, right? So you have to make sure you do it in this particular order since it's a subtraction. Now, just like all the other rules, this one, of course, has a proof for it, but in this video, I'm just going to show you how to apply it to a question. Okay, so let's just move this to the side. And let's try a question here. Let's say differentiate a fraction. So something like this. Okay, so this would equal to, let's just write it like this. A big fraction. Now, in your exams, you'll be given this in your reference sheet, in your formula sheet. But by the time you do enough of these questions, you would have this formula memorized anyway. Okay, so the way I usually memorize it anyway is I always just start off with the denominator, because the denominator is still the same, but we have a squared. And that's the one that we don't differentiate. Okay, now in any of the other questions, I would do a lot of these questions a lot quicker. But just for this question, for the quotient rule, since there's a lot going on, I'm just going to write everything out without differentiating. Okay, just so that we can see how we use the quotient rule. Okay, I'm running out of space. Let's just bring this down. Okay, so yeah, I didn't differentiate anything, and these are not powers of ones. These are actually dashes, okay? I just haven't differentiated it. So if you differentiate the first one, we get minus 2. And if you differentiate this one, we just get 2. The numerator, let's just expand everything. So minus 6 minus 4x minus 6 plus 4x. We have minus 12 and the 4x's cancel out. And this is our result. Okay, so yeah, this is how we use the product rule, the quotient rule. Now I'm just going to show you one last question before I finish this video, and I'm just going to show you a question where you wouldn't use a quotient rule, but a lot of students might think you would have to use a quotient rule. Okay, so remember how quotient was all about like division, right? So if you see a fraction, then you're most likely going to use a quotient rule. But it's important to know that it's going to be a function divided by another function. So if you had a question like, say, for example, the question was differentiate like 1 on like x squared plus 1. When you differentiate this, you could use the quotient rule. It actually would work, which is a good thing about maths. But in this sort of question, you would just say x squared plus 1 to the power of negative 1 and just use our chain rule from there. Like differentiate that, negative 1, x squared plus 1 minus 2x on the outside. Okay, so in this case, the numerator was just a 1. It was just a constant. So you don't really need to use the quotient rule in this case, right? Just change it to index form, and then you can just use the chain rule. Again, like I said, one thing I really like about math is if you were to use the quotient rule on this, it will still work out. But yeah, hopefully you can see my point there. But yeah, that's how we use this quotient rule. I'll catch you guys in the next one.